put this on. So thank you for joining us on this webinar session. We'll be talking about increasing your service and application reliability that is running on Kubernetes with disaster recovery or resiliency capabilities. I myself, I'm Govind Rangaswamy, CEO and founder of Appranix. We are a site reliability automation company. That's how we are differentiating ourselves in the market, because we have some of the unique capabilities that other people do not have. I've been with cloud technologies since 2012. When AWS just came along at the time, was getting popular, and we were producing one of the AWS compatible private clouds. Since then, as a team, we have built and sold a company on the multi-cloud infrastructure management before starting Appranix. Appranix is all about application-centric and cloud-native and everything from an application point of view. A bit of housekeeping before getting started. A recorded version of this webinar will be available after this session. Please, we encourage you to share across your social networks or any other medium that you choose, to whoever is interested in learning about how Appranix delivers application resiliency for applications that are running on the Kubernetes platform. Now, overall, if you think about it, you might have heard different statistics all over the place. About 60% of companies, 60% that do not have disaster recovery plan close within 6 months of that loss. It's a staggering number. I mean, the disaster recovery could come in many forms. So we can all talk about why it is important for companies to have a solid resiliency, solid recovery plan that is really required nowadays. Now, if you think about overall where we are in the market from our point of view, and I'm sure you're seeing this all over the place, organizations are now in a cloud-first world. Right? It used to be like virtualization first, right? Now, companies are either shutting down part of the data center or complete data centers because they don't have time and energy to run data centers anymore. And, some of the newer projects are getting started only on the cloud. So we are in a cloud-first world in the sense that anything that you think in terms of what used to happen in the data center, and a lot of things still happen in the data center, but overall, when you think about the technologies, the management capabilities that you had before, all need to be rethought to make sure that you're in the cloud-first world. And whatever the companies going into the cloud-first organizations demand always-on application reliability. I mean, they are going to AWS thinking that we should be able to run like Amazon.com. It doesn't come down. They are going to GCP and said, "No, Gmail is running all the time." Well, most of the time nowadays. So they are demanding always-on application reliability. So when you think about the new age cloud operations teams, and those operations teams are kind of being rethought as SRE teams, application-specific, application-centric operations with application knowledge, are developers getting into kind of rolling out the infrastructure itself using infrastructure as code. In both ways, what they are investing, what we are seeing in the market is that they are continuously investing in increasing the resiliency of the systems, right? Because if you think about the cloud hyperscale infrastructure itself, the plain virtual machines, the storage systems that the hyperscale cloud providers have are all pretty reliable compared to what it used to be. While we ran those systems, individual systems, different vendors, and so on, they all needed to kind of work together. That's not the case anymore. This is about, we can now afford to move up to the application level. And you can continuously automate. I mean, it's a toil out there. When I say toil, it's like, digging a ditch or something. You are working hard all the time to manage more devices, more of everything within the shorter period of time. So you got to automate more. That's taken for granted. But what are you really automating, right? We need to automate from an application point of view. On the other hand, businesses demand faster deployment of applications. So you have to balance between faster deployment and also resiliency or reliability of the applications themselves. You don't have to really completely kind of take one or the other, right? You got to have a system that can actually help you to deploy as well as keep the reliability part. You know, one of our customer Progress Systems deployed our system on top of Google platform, and they've been really happy in terms of running their application, which is 24/7. You know, they cannot bring down their application unless, you know, the schools take some kind of a vacation at some point in time, but the students are 24/7 anyways. So we are helping them to run their application, meaning the entire SaaS system for higher education continuously 24/7. So that's the reliability story that we have with respect to what we do in the marketplace. So when I go and talk to enterprises that have gone to the cloud or that are putting cloud native application infrastructure like Kubernetes, I ask them, you know, when did you really test your resiliency, right? Everyone is working hard on the production environment. You know, they need to run at least some kind of a cluster upon which the applications are getting deployed through the containers or the virtual machines that are, you know, a lot more nowadays in terms of looking at configurations and so on the hyperscale cloud. And I asked, you know, did you know your typical data center style resiliency or recoverability based on the VM backup and recovery mechanism is not sufficient at all for always on application. So you have to really rethink about what's going on. And thinking about that, you know, the disasters are not decreasing, they are actually increasing. You know, as we speak, there's a polar vortex. Probably I'm spelling it wrong. Vortex is kind of upon most of the regions of the Northeast and the Midwest completely blanketed. So, you know, a lot of planes are kind of grounded. You cannot even run them. So the number of disasters are increasing every day. That is one part. So you got to be prepared for that natural disaster scenario. That may not happen all the time, but you got to be prepared because the downtime cost is, you know, $5,000 per minute on an average across the board. Second is ransomware attacks. I mean, this is increasing day by day. Some of the examples, Atlanta government spent about $52K in the ransomware payment, right? Just $50K, that's totally fine. But they spent about $2.6 million to recover from the ransomware attack. FedEx had to restate the financial report to the tune of $300 million. And its quarterly profit because of NotPetya attack, the ransomware attack that attacked a lot of this system, very large companies, including a BT was attacked at some point in time last year. So, you know, if you think about it, this ransomware is really, it's attacking all over the place. It's something that you got to be prepared for at any point in time because it's an unplanned event. Third, the prescription from the hyperscale cloud vendors themselves, because they know, you know, if you are running your applications in one of the regions and one of the zones of a particular region, you know, you got to architect your cloud infrastructure appropriately for your applications, at least to start with second zone reliability. Just on the infrastructure alone, you know, they don't know your application, so you have to really design your applications appropriately to take care of a situation where the zone goes down, and stretching that to the second region itself. So if one of the regions is completely failed for, let's say, a Spectre attack or some kind of a lightning strike, you know, that recently happened with Microsoft data centers in Texas, you know, the entire thing comes down, entire region comes down. Then, you know, are you prepared for that instance? Have you really tested your application resiliency lately? So you got to be kind of prepared for the region or zone failures. And finally, it is not the minimalist of it or the least of it. Human error when you deploy applications, when you change the configuration, causes a lot more problems. 22% as of 2016. This is based on one of the largest studies by Furman Institute that outlined, 22% of configuration problem, the downtime happens because of human error, right? So, having, you can go on in a number of other ways, why the downtime happens, why an unplanned event happens, even the planned instance. If you want to deploy your new applications, you have to now think about, hey, should I bring down that production instance? There's always a fear of kind of deploying the next version. Why should you, right? If you have a right system, you can actually do it with confidence. So given that, we offer a very differentiated system that's not available in the market today. Other people will catch up. That's expected. So we offer a unique site reliability automation platform, SRA platform, for application resiliency, right? By taking care of the entire infrastructure that corresponds to an application or multiple applications together. So we offer peace of mind with a policy-based approach that takes care of cross-region and zone resiliency. Reliability confidence. If a system allows you to, even through a Slack chat or with a click of a button, if you're able to recover the entire application and test it, right? You would be pleased to test more and more. You don't have to incur the cost of infrastructure because you can get rid of that infrastructure after testing. So that increases your reliability confidence. Third, fastest environment recovery. It is not only for recovering the pieces of the infrastructure, the entire application environment gets recovered. And guess what? You could use this capability for multiple other use cases. For instance, you can take a quick save type of thing. Save that environment in one of the regions, copy it to another region, deploy your latest application changes to the production environment, thinking that the recovery environment is ready to go for you. Or you can even switch your application load balancer or DNS information to the West Coast, thinking that you're running on the West Coast, while you deploy the production environment changes and on the East Coast, for example. So likewise, you could use a system for multiple other use cases, not only for DR. And it gives you the lowest possible cost of ownership, because we are pretty much utilizing all the native capabilities on AWS or Google or and so on. So you don't need to have other systems in place. So if you think about it, having put together all of that, let's take an example of a system or a set of applications running on a Kubernetes environment. So in this case, your applications, your microservices, right? Whatever the system boundaries that you have, assume that you are running on Kubernetes, the entire Kubernetes system. If you have put together the Kubernetes multi node HA type of cluster, you will know the complexity of running that kind of an environment, right? We are running 350 containers on 100 node cluster that runs between two different regions. In our case, in our own system uses our own platform to run these services, and we use Kubernetes as well as virtual machines. Now, this Kubernetes, cannot run isolated. You need to run on hopefully a much better infrastructure, right? So you have to run on some kind of a cloud-like infrastructure that's easy to kind of create and auto-scale and so on. So you have to really think about the cloud infrastructure itself with all the services, including compute, storage, network, security groups, and the load balancers, DNS, and so on. So you have to really think about, not only just deploying it, you're actually running the production environment. So your applications, microservices are running on Kubernetes platform using containers, and the Kubernetes platform itself is running on the cloud infrastructure. This is something that we will demo in a short while. Now, if you think about it, if any of these components go down, if let's say a zone itself goes down, the configuration changes really kind of destabilize the entire environment. What do you do? So current approach in the market is that, it's a partial failover. You can scramble to put together another Kubernetes. You deploy another Kubernetes quickly, and then hopefully things will come up. You have to deploy the containers and, do some custom automation. Then you have to manage the snapshot lifecycle because you're not really copying the configuration that you captured before. God only knows what kind of configurations were there with the nodes, with the load balancer configuration. So, you will have to think about bringing in other capabilities. If you're really running combination of virtual machines and containers, you have to really think about bringing in third-party backups if you're not using the capabilities of AWS. And then you put together, hopefully, if you can do it, great. Otherwise, you end up kind of inviting consultants. And, there are different categories of consultants. You'll have to really get certification of these consultants, whether they can actually do it or not. So expensive consultant. At the end of the day, there is no guaranteed application reliability, right? If you bring up those applications in another region, another zone, right? If it were to fail in the primary side, there is no guaranteed application reliability. And then you end up having an automation system nightmare. How long can you hold this particular thing, right? At the time, there is, you would wish that there is some capability, hopefully, is available in the market that could help. And Appranix is one of those capabilities, right? So in this particular case, what we are able to do is that you have the entire infrastructure running, the cloud infrastructure, Kubernetes infrastructure with all the various services, and your applications. And we take care of continuous data orchestration, continuous configuration replication, and continuous application platform log analytics so that your applications actually come up. So with that, we pretty much recreate the entire infrastructure for you, entire application infrastructure for all the platforms, everything for you. So we create the cloud infrastructure. We create the entire Kubernetes configurations, as if you redeployed everything. And then we make sure that all the load balancers and, all the security groups and certificates, registering those certificates with individual nodes, you have to make sure that all the nodes are properly registered in the Kubernetes. So overall, your applications need to run. And that's what we can do, right? We'll show you a demo as well. So at the end, if you think about the overall capabilities of our platform, you don't need a third-party management system because we can directly use all the capabilities of, let's say, AWS or Google or Azure and so on, in terms of data management by managing the data infrastructure, storage infrastructure, and so on. Significantly reduce the risk with an automated service. Why? If you're really thinking of DR, if it's a chore, to an extent, right? Yes, you need it. Even for compliance reasons, you need it. But you got to have the confidence because it's not about just compliance at the point if something were to really happen. And ransomware attack is like every other day I keep hearing something. And you got to have the guaranteed application reliability, right? You should be, satisfied that yes, if something happens, my systems will come up, right? So that's what we do. So we are a site reliability automation SaaS platform. So you don't have to install anything to get started. It's very, very simple to get started, which significantly increases your reliability of the applications. And we have been recognized by Enterprise Management Associates as one of the top 3 platforms. And we are a secure enterprise SaaS that has 99.9% SLA. So this is something that we guarantee. Otherwise, we end up paying a penalty to you guys if you end up buying our service. To get started, it's very simple. You can pretty much go to Google, type Appranix and AWS. You will get to the marketplace item, and the marketplace, you can simply subscribe, and site reliability automation comes up. You subscribe from here, assuming that you logged into your AWS console, and that's all you have to do. Once you click here, it will automatically allow you to create an account. and that account will let you just configure and go. So for the purpose of the demo, what we have done is that we have already created the necessary components here, because webinar is limited, as we know. So once you log in, you have to register your cloud. So give a cloud name, access key, secret key, select a region, select a target region, and also you have the required IAM policy. You can just click and it will give you the IAM policy. You simply cut and paste the entire thing as is. It's cut and pastable text here. You're ready to go from the configuration point of view, right? So once you're done with it, that's what we did. Cloud type is AWS. Once you configure the cloud, it will automatically go and discover everything for you. In this particular case, you can see we are running a multi-master HA Kubernetes environment. You have 3 masters and 3 slaves running. You can see the configuration of all the nodes on AWS. And if you look at the console itself, let's go to the East Virginia region. Here, you have the East running the instances, 7 instances here. All the instances are live and they are kicking. That's all totally great. And you have the volumes are properly configured in the backend. All the security groups, load balancers are configured as well. I can see multiple load balancers, and instances are registered, and elastic IPs, all the configurations that are required from an infrastructure service perspective to run your Kubernetes environment. So that is just a platform. So the platform runs here, right? You have the Kubernetes UI. I will have to just log in again. I have the login here. So if you look at the namespaces, multiple namespaces, some are internal. One is that is of interest is SOC shop. So this is a good distributed application. So the pods started, you'll see while the pod is starting, we'll see some failures, and then once the pods are ready, the failures will go away. And that application looks like this, right? So we have a visualizer to visualize your containers and so on. So you look at the pods, multiple pods, and you can also look at the nodes in terms of how the nodes are kind of working to give you that application itself. So you see multiple containers are running here. The ones that are really interested in this namespace, which is very specific to the SOC shop. So those containers are running once. Let's see, any containers. So those containers are running here anyway. All right. So I think it's just hide and contain. So all these containers are running here. The application itself, the SOC shop application, is basically a real-world e-commerce type of application, right? Where you can actually go and buy the socks. So we love the socks. This application catalog. If you look at the catalog itself, Holly, I will add the catalog item. Couple of more socks, different socks. By the way, this is a real shop. If you happen to hit, it's a UK site that sells the socks, and they are generous enough to kind of open source their architecture, and company put together the container-based architecture here. So everyone uses SOC shop application. I think VWorks, thanks to them, they did a great job in terms of open sourcing from that SOC shop application. So, this is a real world application that runs on Kubernetes, right? And what we are going to do is to, simulate the kind of a failure of this entire environment. Then we are going to bring back the entire thing using Appranix. So in Protect Service, so once you kind of protect the environment here, you can go to creating an assembly, And that assembly is basically a representation of all the resources here. So you can see how much we have gathered in terms of compute, in terms of DHCP options. These are the infrastructure that is required, kind of assembled to give you the application with respect to the platform itself. So here you can simply say, protect this application infrastructure, entire application infrastructure, with a couple of snapshots. So the only thing that needs to be kind of kept warm, everything else is just captured continuously, right? And the data is one, it's difficult to kind of replicate. So we kind of replicate the entire node system in the backend. And you can see the timeline once you start, the protection policy is the only one that you have to kind of create. So if you create a new protection policy, it's almost, I think it's a backup system, right? So sometimes you'll be able to get rid of your backup system as well. So daily, weekly, monthly, and yearly, you put a retention, and then Appranix takes care of the rest in terms of, making sure everything is captured at that particular point in time. So every hour, we are capturing it. You can go back and look at what are the captured ones, all the information about the entire infrastructure here, and multiple points in time. So we are going to use, we don't have to use the latest one. You can just simply go to the previous one and then see if we can recover from that point onwards, right? Recovering the latest one is one thing, but if you could go back and recover, let's say you deployed something here and the replication was happening at the time. So, if the entire environment is down on the production side, how do I recover from the previous timeline? So you can go back and recover. That's another key one. So what we are going to do is to intentionally bring the entire East Coast environment. So I'm going to just turn off this. I'm looking at the load balancer. I don't want to turn off the load balancers here. Instances. So here, go to the instances, actions, state, stop all of them. So we are going to stop all the Kubernetes instances as if they are dead, for various reasons. All the nodes are down. So once they're down, you can see once this is not going to work, Kubernetes is not accessible, and your maps are gone, your application is gone as well, right? Entire thing is done. So what we are going to do is to bring that application back from the dead. So we'll go to 11 o'clock time frame and then say this is protection. So all the logs are saying that everything is great. It was a success. We are going to recover that entire environment. So it's just one click. We are going to fire off the recovery. So you can see the recovery will start. It will start doing its magic in the back end. Right? It's going to make sure that all of the backend configurations are brought up. As I mentioned before, all the configurations of all the infrastructure components, all the load balancer components, all the networking, all the security groups, everything will have to be recreated as if nothing happened, except the data component, right? The data has already been copied. They are kept in warm state on the West Coast. So if you go to the EC2 management console on the West Coast, the one that we have configured is the Oregon environment. So if you go to Oregon, you'll see the warm environment is basically the snapshots. The snapshots are already kept. We have been capturing latest one, that is today. They are all available, completed. And the instances are getting started. So you can see 5 instances are now here. They are all starting. Some of them are currently running. And we'll have to make sure that everything else, right, needs to be configured as well. All the security groups need to be brought up. There were only like 7 or 8 before, and now we have to recreate all of them. Elastic IPs need to be recreated, reconfigured, and the load balancers need to be recreated because the load balancers were configured on the East Coast. Now we'll have to reconfigure all of them on the West Coast. So there are only 3 here. You'll see a lot more load balancers getting created. all of that need to be recreated again, right? Otherwise, your system is not going to run. Your entire application is not going to run. So while this is getting recovered, you can see the progress here. So you can see now the load balance is getting created. All the subnets, routes, all of them are creation in progress. So it will take about 10 more minutes maximum, and it shouldn't take 10 more minutes, but to configure everything together will take a few minutes to complete, because we are now bringing up the entire Kubernetes environment, the application that SOX application that was running on the Kubernetes environment, and the entire infrastructure on the AWS as well. You have to recreate as if nothing happened, because your production environment is now down, completely down, right? So what's the guarantee that it's going? You cannot fix unless you know what's happening on the production side, and the only thing that you have is on the recovery side. Luckily, you have hopefully Appranix to bring the entire application up. So once these application instances are running, so they are all running, you can see, I cannot control AWS. You can only schedule a lot of things at once on the AWS side. So they are all initializing. Let's look at the load balancer here. So you can see all the load balances that were configured on the East Coast for the Kubernetes are recreated. And by the way, the load balancers need to be connected. The load balancers need to register the instances of the virtual machine. So you have to make sure that those come up. So unless the EC2 instances come up, the load balancers will not be registered. So we make sure all of that happens automatically in the case of a failure. So once the instances run here, they are in a running state, the load balancers will come up. But it's only one thing that we ask customers to kind of customize a little bit, which is the Route 53 configuration. So Route 53 configuration here has the East Coast pointing out. So you can see the East Coast route configuration. So app.host.appranix.info is the app host that was the application pointing to the SOX application, and the Kubernetes UI. This is that KAS, Kubernetes as a Service UI here, and application maps. So they need to be realigned as well. So for that purpose, I have a script that I kind of give it to the customers to run, because it all depends on their application, so they can very easily customize it. It's one shot. They know their application, they know their registry entries, so it's easy for them to kind of run. So I have pre-configured that application here. What I have to do is to make sure that it is pointing to the west and fire that DNS change. So while that is doing, I can see how this is going to be reconnected. It's changed over to the west one. So you can see the Kubernetes host is up and running. So hopefully this is ready to go. I'm waiting on that one. Should be up and running as well. The one thing that we don't typically control is how load balancers actually kind of register here. So still you can see the load balancers need to recognize the instances. Otherwise, it's difficult to bring them up appropriately. This is something that AWS guys are kind of moving customers from a classic load balancers to the new load balancer. So sometimes we see finicky, recovery situations because of the classic load balancer. So we are supporting the network load balancer and the application load balancer separately. In this particular case, we didn't do this. So hopefully these instances come up. So you can see the control plane. This is basically the Kubernetes control plane is up and running. Still the other instances are not yet running. We'll have to wait a few more minutes. is waiting to connect. So we not only check whether the connection is established with the load balancer, but also we make sure that we can touch the application to make sure that they are running. We make sure multiple aspects of the system itself. So bringing up the entire Kubernetes system requires a knowledge of how the Kubernetes system runs, and also how the applications on the Kubernetes itself run as well. So multiple checks are performed based on the logs in the backend, and also make sure that the configurations are proper as well. So while this is happening, hopefully, sometimes we cannot control what AWS does, right? And so as you can see, the application visualizer came up. So as if nothing happened, right? So this application, the containers are running, the pods are running, the nodes will come up, the nodes are connected, all the nodes are pointing to the West Coast, and the application might take a bit of time to come up because the pods need to be deployed appropriately. Let's see if the UI has come up or not. But as you can see, and our visualizer gets information really, really quick. So that is one reason why, we are able to quickly point to this one. So as you can see here on the East Coast, so going to the East Coast where the Kubernetes environment was running, that environment is now completely down, right? It's none of the systems are running, right? And the Route 53 configuration has been pointed to the West Coast. So all of that is pointing to the West Coast region. And all the load balancers are often all down. So on the West Coast, on the Oregon side, we have the application being brought up. All the infrastructure is everything running. And the snapshots are properly hooked up. The security groups are done. All of the configurations are automatically handled for you so that the application actually runs. So that is overall scenario here. Let's see if this application is brought up. Sometimes, I cannot trust. So the UI is up now. So you can log into Kubernetes UI. I have to give the token again because it's a new instance. So I have to make sure that this is perfectly kind of handled. Token, enter the token. And there you go. The Kubernetes system itself is running. So you can see various namespaces. SockShop is the application. And as you can see, there is one pod that's getting created. The good thing about Kubernetes is that Kubernetes will try again and again to make sure that the pods are properly deployed. So you can see other components of the applications are up. Hopefully this is also up from a point of view. Perfect. So you can see the SOX application is up, and that's you can go and run it. If I use the latest snapshot, we would have seen the 3 items in the cart as well. So this is something I should have pointed out. If you modify anything to make sure that you configured the policies appropriately to capture the latest data, otherwise you won't get the entire data. So just to make sure that you capture all that properly. So given all that, our system is not only just the product service that we are offering on the platform. We can also manage the production Kubernetes as well with a AI-based self-healing system if you wanted to. But you can get started with our AWS Marketplace service that's already available. Anyway, so let me stop here and see if there are any questions from your point of view. Any questions? You can raise a hand, or you can chat with me on the chat window. Pretty much all the options are open. Okay, any questions? All right, I'm sure you're all chilling out, and hopefully this webinar was useful. There is a question coming in. There's a question. How come there was a question, but the question kind of disappeared? Yes. Is there a trial period? Yes, indeed, there is a trial period. Please contact us separately. We'll be happy to offer you a trial period. You can test it out, make sure that it works for you, and we can go from there. Absolutely. Any other question? And do you provide professional services consultation? Yes, initially we do provide professional services, not a problem, to make sure that you are completely on board with our system, to make sure everything runs okay. We won't just, we're not, here is a product, deploy it and done. No, we don't do that. The one good thing about our SaaS service is that we can pretty much handhold you towards proper implementation right over the web. So that is one of the good things about any SaaS system running on the cloud platform. Absolutely, Kakan. Yes. Okay, and thank you, Gajanan. So please contact us separately. We'll be happy to set up the system for you. It's very, very simple, as you can see. We can go from there. Okay, all right. So I think we can conclude the webinar here. Really, really appreciate your time. I know you have plenty of other things to do, and we are happy that you chose to join this webinar, and hopefully this was useful, and we'll be able to help you in terms of securing and running your Kubernetes systems reliably on the cloud platform. Thank you very much.